Well, hello there. I hope you're doing well. In this video, we're going to be talking about chapter 2.3, radical functions, or solving radical equations, pardon me, graphically. The things that we're going to be focusing on today are relating the roots of a radical equation, or in other words, the solution to radical equations, and the x-intercepts of the graphs of those radical functions. And also focusing on determining approximate solutions. So instead of exact solutions using square root signs, just decimal solutions rounded to a certain amount. You're able to solve lots of equations both algebraically and graphically. Algebraic solutions sometimes produce what are called extraneous roots. And we'll talk a little bit more about that in a few minutes. Whereas graphical solutions don't produce extraneous roots. However, algebraic solutions are generally exact, but graphical solutions are usually approximate. You can solve equations, including the radical equations, graphically by identifying the x-intercepts of the graph of the corresponding function, and we're going to be talking about this. If you'd rather just follow along in your textbook, it all starts on page 90, or if you just want to follow along while listening, that works too. Starting with example number 1, relating the roots and the x-intercepts of a graph of that function. First of all, determine the root, or roots, of the square root of x plus 5 minus 3 is equal to 0, algebraically, so using math. The first thing we need to do is determine restrictions. This is going to become tedious, but it really is necessary whenever we're dealing with any of these equations or functions. Since we can't take the square root of a negative number, x plus 5 has got to be greater than or equal to 0. Or in other words, x must be greater than or equal to negative 5. With that restriction determined, the next step is just to solve it. So add 3 to both sides, square both sides, and then subtract 5. Getting a single root, or a single answer, of x equals 4. And you know what? I'm gonna go back. I thought there was one more step. Just to double check, we make sure that that is okay based on a restriction. So our restriction was x must be greater than or equal to negative 5, and 4 is greater than or equal to negative 5. So that is a root that we can use. It's all okay. Now for B, let's relate the roots and the x-intercepts. To find the x-intercept of the graph, we just want to graph the function. The best thing to do is throw that in your calculator. Y is equal to the square root of x plus 5 minus 3. And check where it crosses the x-axis, the root. It has a single x-intercept found at x is equal to 4. Wow, 4, 0. There it is. Just what we were looking for. The value x is equal to 4 is the 0 of the function, because the value of function is 0 when x is equal to 4. The roots to a radical equation are equal to the x-intercepts of the graph of the corresponding radical function. And that's example number 1. For example number 2, we're going to solve another equation, but this time there's an extraneous solution. An extraneous solution is a solution that appears to work or comes out when we do the algebra. But if we then reverse the process, we see that it actually is not a valid answer. And you'll find these in places where we have square roots sometimes. Because when we square things or square root things, odd things happen with our answers. Start off with the same thing. We have the square root of x plus 5 is equal to x plus 3. Square both sides. After we've squared both sides, we have x plus 5 on the left side and x squared plus 6x plus 9 on the right side because, perfect square and all. Then putting everything on one side, or subtracting the x from the left side and 5 from the left side, we get a more simplified answer of x squared plus 5x plus 4 is equal to 0. Solving that, which is in your textbook, they show that a next step. For some reason, they don't have it here. That is the same as 0 is equal to x plus 4 times x plus 1. Because 4 times 1 is equal to 4, and 4 plus 1 is equal to 5, if you remember back to solving these equations by hand. Since x plus 4 is equal to 0, x has got to be equal to negative 4. Or, since x plus 1 could be equal to 0, x is equal to negative 1. As a reminder, when we factor quadratic functions such as x squared plus 5x plus 4 and get the two answers, x plus 1 times x plus 4, we have that equal to 0, which means that either x plus 4 is equal to 0 or x plus 1 is equal to 0 because anything times 0 is equal to 0, or both of them are equal to 0 because 0 times 0 is also equal to 0. Hopefully that's not super confusing. If it is, just ignore what I said and let's continue on. Now we have to check. Make sure that it works. So we take our first solution, our first answer or root, negative 4, and plug it back into the original equation. Our left side was x plus 5, the square root of x plus 5. And if x is equal to negative 4 plus 5 is 1. The square root of 1 is 1. Okay. On the right side, we have x plus 3. Negative 4 plus 3 is not equal to 1. It's equal to negative 1. So the left side does not equal the right side. Negative 4, even though it looks like it should be an answer, is not. It's extraneous. Checking then with the right side, or pardon me, the other answer, negative 1. Negative 1 plus 5 is equal to 4. The square root of 4 is 2. Negative 1 plus 3 is equal to 2. The left side is equal to the right side, so x is equal to negative 1 is an acceptable root. There are times when there are no extraneous roots, so both roots will be correct. There are times when both are extraneous, though that one doesn't happen very often. The only solution to this, then, is x is equal to negative 1. Next, we'll use graphing. We'll use graphing to solve this same question. There are two ways that you can do it. Either you can put both sides of the equation onto one side, so subtract one side and put them all equal to 0, and do that as a big equation. Or we can graph both sides separately, which is what we're going to be doing here, and see where they intersect. If we put all of it into one big equation, it's where that big equation crosses the x-axis that becomes our solution. If instead we graph it as two separate graphs, like in this case, so the square root of x plus 5 and x plus 3, it's the place where they intersect that gives us the solution. And you can try both in your calculator if you want. You could say, you can do this, have x or y1 is equal to the square root of x plus 5, y2 is equal to x plus 3. See that they intersected, x is equal to negative 1. And then you can do one big equation of the square root of x plus 5 minus x minus 3. Put that into your calculator and you'll see there is a new graph, but the new graph crosses the x-axis or has a 0 at x is equal to negative 1. Either way, we find that the root or solution to our equation or system of equations, depending on whether we made a big equation or put two equations together, is x is equal to negative 1. You'll see that the extraneous root, positive 4, doesn't even show up. Or negative 4, pardon me, doesn't even show up, so we don't have to worry about it. That's the benefit of doing it graphically. So here we're going to use graphs to solve the equation and just approximate the value. So instead of trying to do all of the algebra, we'll just do it using a graph. So, and express to the nearest tenth. And so here's our options once again. We can rearrange the function so that it's all equal to 0. So we could take these two sides of the equation, the square root of 3x squared minus 5 is equal to x plus 4, and then subtract x and subtract 4 to get a huge function of the square root of 3x squared minus 5 minus x minus 4. And from that, make the graph. The values of that x-intercept of the graph are going to be the same. And so I don't know why there's not a graph. There's the graph. I just didn't push the button. There we go. So if we graph it, it actually makes what looks like two graphs. Even though it's a single function, it looks like two graphs because of non-permitted values. And you'll see that it crosses the x-axis at 2 points, negative 1.81 about, and positive 5.81. So the two solutions to this equation are x is equal to about negative 1.8 and x is equal to about positive 5.8. We could have also graphed it like we did in the last question as two separate graphs. So the square root of x squared, 3x squared minus 5, and x plus 4. Graphing those two functions, we'll see what looks like very similar, two different lines, but then a third line that goes through both of them. And the place where that third line intersects the other two is going to be our x values of our solution. So once again, it's negative 1.81 and positive 5.81. And in your calculator, unfortunately, I don't have it set up to show you, you can find out those exact values by using the calculate function. So on your calculator, you hit the second button, and then I believe it's the trace button, which brings up the calculate menu. And there is an option that is intersect. It'll ask you to choose the first line. So you choose a place near the first point that you're looking for the intersection. So maybe on the left side over here, and hit enter. And then it'll switch to the other function, and you try and get it to about the same place, and you hit enter. And then it'll ask guess, and you hit enter around where you think it's going to be. And it should give you the solution negative 1.8, 2.1. And then you do the same thing, just using the right and left keys to move your crosshair to the different intersection. I'll try and show you in class as well, because I'm sure this isn't the best way to discuss it. For part B, so that's part A. For part B, it's verify your solution algebraically. This is the messier part. So if we do it in algebra, first of all, once again, we have to determine when our answer is defined. So if we solve for x, first of all, we have x is, since it's underneath of a radical, or underneath the square root sign, 3x squared minus 5 has to be greater than or equal to 0. So 3x squared has got to be greater than or equal to 5. X squared has got to be greater than or equal to 5 over 3. And then the confusing part, the square root. When we take the square root, we have to do it a little differently. The absolute value of x has got to be greater than or equal to negative 5/3. Because a number squared, a negative number squared becomes positive, and a positive number squared stays positive, we have to look at two different cases. We have to look if x is greater than or equal to 0, then x is greater than or equal to positive 5/3. But if x is less than 0, then, or in other words, if x is a negative number, the square of that number will be positive, but the unsquared version has to be less than negative 5.3. And I know that's kind of confusing, but trust me, it's true, I guess. And then we have to do our two solutions. And to do it algebraically, you got to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a. And I think that's on your formula sheet. It should be on your formula sheet. And to get it into that form, the normal quadratic form, first of all, need to square both sides and combine the like terms to get our a of 2, our b of negative 8, and our c of negative 21. Obviously, this is super messy. I would never make you do this generally, but they might make you do it on the test. It simplifies to 4 plus or minus the square root of 58 over 2, which is equal to approximately 5.8, or negative 1.8. Hey, look at that. Look at that. Finally, example number 4, solve a problem involving a radical equation. And so we got this roller coaster here. And this is a physics equation, physics 20 equation. Vf squared is equal to Vi squared plus 2AD. And so the engineer is using that equation to model the velocity in feet per second after dropping a distance in feet with initial velocity of V naught, which we would normally call Vi, in feet per second. Acceleration is given as 32 feet per second squared. The initial velocity is 10 feet per second, and the maximum value that we can have is 120, or the maximum velocity, the Vf, or just V in this case, is 120 feet per second. What we want to do, I mean, this is a physics question. You know how to do physics. So this is almost, I don't know, kind of silly to do. So this, you could totally graph it by just substituting in it everything that you know, and then moving the 120 to the other side of the equation. So the square root of 100 plus 64x minus 120. Graph it, and you can get that. You find the answer where it crosses the x-axis, or in another way, you want to see, if you want to see where the velocity is 120, just use the right side of the graph, so the square root of 100 plus 64x. And then, so use that as your y1. As your y2, use 120. And you will see, or just look at your table, and you will see at what point y is equal to 120. And it turns out to be 223.44 approximately. So approximately 223 feet. Key ideas then. Hopefully that was clear. The textbook might be a little clearer. Once again, if you have questions, I will definitely answer them when I'm back. Key ideas. You can solve radical equations algebraically and graphically. The solutions or roots of the radical equation are equivalent to x-intercepts of the graph of the corresponding radical function. You can use either of these two methods to do it. You can just graph the corresponding function and identify the values of the x-intercept. So make one big function, subtract either the left side or the right side from both sides, and get a big equation equal to 0. Or do both equations as two separate graphs, and where they intersect will be your solution. So that's it. If you have any questions, please do let me know. I'll try my best to help you, either online or in person. Hope you have a fantastic day. I will talk to you later.